everyone, this is KC7 Intro to Quadratics for Integrated Math 2. First section is on vertical motion, section 1.3. Okay, so in this section, we're going to be talking about linear versus a quadratic function. Now, if you recall, linear functions you've already seen. If I graph this linear function, it looks like a straight line, either increasing or decreasing. Right now, this graph specifically crosses the x-axis here, which is our x-intercept, and the y-axis here, which is our y-intercept. Now, a quadratic looks way different. A quadratic function looks like a U. Okay, it's either a U or an upside down U. Okay, so if it is a graph going up, we say it is positive, or going down, then we say it is a negative graph. Now here, where it starts to curve, this is called the vertex. Okay, at this point here, again, our y-intercept. And if you notice, this crosses the x-axis twice. So this graph actually has two x-intercepts. Now, most of the time, quadratics will have two intercepts. They can have one or none. They are actually called imaginary intercepts, which you will really talk about junior year mostly. Okay, so for example, our first example, I want you to use technology to sketch the graph of the following functions. And to do this, I want you to use Desmos. Okay, so you could use your graphing calculator if you like. I can show you how to do that in the classroom, or you can use Desmos. So that's what I'm going to do. I'm going to go back to Desmos, and I already have it on here, and I plugged in my function. Now notice that you only have to plug in this section of the function. Okay, you do not, you do not need to include that f of x part. It's only the right side of the equation that you need. Okay, so if I go on Desmos and I click on my graph, the points that are important are going to pop up. You're going to have your y-intercept, your x-intercepts, and your vertex that you need. So what I'm going to do is I'm going to draw or sketch a graph with those points. Okay, now it doesn't have to be perfect. Okay, just do the best that you can. So I'm going to graph. And I have that my vertex was at -1, -4. I'm just going to write this for reference. My x-intercepts, I had two of them, was at -3, 0, and 1, 0. And my y-intercept was at 0, -3. So I am going to plot those points on my graph. Okay, so I have -1, -4, which is here. I have -3, 0, 1, 0, and 0, -3. So my graph will be pointing up, going this way, forever and ever. That's it. So those are your key features that you need in order for you to graph a quadratic function. So we're going to go ahead and do the same thing here. Okay, so I'm only going to plug in this right side of my equation and figure out what the vertex is, the x-intercept, and the y-intercept. So I'm going to go back to Desmos. I can erase this function and plug in x squared plus 3x minus 2. Okay, so here is my function. I can click on the graph and I have points on here. Now notice that these are decimals, and that is okay. I'm only going to round to 1 decimal point. Okay, again, this graph does not have to be perfect. Okay, so my vertex was negative 1.5 and negative 4.3. If I round to 1 decimal point, my x-intercepts were negative 3.60 and 0.60, and my y-intercept is at 0, negative 2. So I'm going to go ahead and plot those points. So negative 1, negative 4.3, or negative 1.5, excuse me, somewhere here. My x-intercepts here, and my y-intercept here. So my graph is as follows. That's it. Okay, so I want you to go ahead, before I move on to letter C, I want you to pause the video and plug this into Desmos. Okay, plug it in, tell me what my intercepts are and what my vertex is before I complete this problems. Okay, so I'm going to go back to Desmos and plug in my function. So I have a negative x squared this time minus 4x plus 5. Okay, so here's my graph, and my intercepts are as follows. Okay, so I am going to go ahead and copy that graph. So my vertex was at negative 2, 9. X-intercepts were at negative 5, 0 and 1, 0. And my y-intercept was at 0, 5. So graphing that, negative 2, 9, that's way up here. High graph. So here, x-intercepts at negative 5 and 1, and 0, 5 was my y-intercept. So this graph is going down, and you will notice that it is going down because of this negative. Okay, that means that my graph is flipped upside down. All right, now vertical motion is real world situations, okay? So I have an example here. It says, given s of t is equal to negative 16t squared plus 50t, describe the height of a soccer ball being kicked over time. So you're talking about the height and time. So I have a graph here. My time is always independent, so that's here. And my height is dependent, so that's here because that's my y. Okay, so what I'm going to do is, again, I am going to graph this function in Desmos. So I have negative 16t squared plus 50t. Okay, notice that when I plug it into Desmos, I am going to use the same variable I've been using. I'm going to use x. Okay, so negative 16x squared minus 50x. It doesn't matter if you use t or x or anything like that. In your problem, you can use x all the time. Okay, so here is my graph, and I can again get my coordinates. Okay, you can look at this, and I am actually going to sketch it really quick. Okay, so it looks like this. Now I only care about, because we are talking about the height of a ball, this will technically go down forever in both directions. However, you're talking about a soccer ball. We don't say that we have negative time. So time doesn't exist in the negative coordinate plane because of that. Okay? And the same with height. We don't say that we have negative height. So really, where these dotted lines, it stops there. It starts here at 0 and it ends at some point here, wherever my intercepts are. Okay, so I want to know the height in feet of the ball after 1 second. So what I'm going to do is at 1 second, where am I here? Oh, sorry guys. I made a mistake here. This should have been plus. There we go. At 1 second, I am going to see where my graph is. As you can see that I'm moving this until I get to 1 second, which is about here. So at 1 second, I would say that my height is 34 feet. It's at this point right here, 134. So 34 feet is my answer. It says, how long does it take the ball to hit the ground? So it starts at 0, and how long is my other x-intercept? Right, so again, my intercepts here were 0, 0 to 3.1250. So it took the ball 3.125 seconds to go back to the ground. 3.125 seconds is my answer. And then what is the maximum height of the ball? That would be my vertex. Okay, remember that x is talking about time and the height is y. So I'm looking at my y coordinate. That would be 39.063. So 39.063 feet. And then last but not least, how long did it take to get to that height? Again, I'm going to my vertex, and that's 1.563 seconds. That's all.